Hello. This is video number 5 of momentum and impulse. That is the conservation of linear momentum. Remember, we said the momentum is the product of mass and velocity. It has both magnitude and the direction. The SI units for the momentum is kg meters per second. Please don't forget to subscribe and share. The principle of conservation of linear momentum states that in an isolated system, the total linear momentum is conserved. In an isolated system, the total linear momentum is conserved. So there is another term here, isolated system. So when we say the system is isolated, the net external force is equal to 0. Therefore, the system is isolated. It is isolated when the net external forces, net external force is equal to 0. Therefore, we say the system is isolated. So the external forces are Fk, force applied, tension, what else? Except for Fg. So the Fg is an internal force. The other forces are external forces, right? So this is the principle of conservation of linear momentum. In an isolated system, the total linear momentum is conserved. What does that mean? The momentum before collision, the sum of the momentum before collision, the sum of the momentum initial is equal to the sum of the momentum final. Which means if there are two objects that are colliding, let's say we have ball A and ball B, they collide. Let's say this one is not moving, for example, then this one is moving towards this one. So when they collide, if the system is isolated, the momentum before collision, the total linear momentum before collision will be equal to the total linear momentum after the collision. So which means we have the sum of the momentum. This is the sum, meaning that you add the initial momentum of A in this case plus initial momentum of B. It must be equal to the final momentum of A together with the final momentum of B. That is the conservation of linear momentum. So remember, we said the momentum is mv, which means we have mv initial of A plus mv initial of B, which is equal to mv final of A plus mv final of B. Okay, so this is the main formula, then you work on it, right? That is the principle of conservation of linear momentum. So if the object is not moving, which means the momentum is 0, because you just substitute by 0 here, all right? Then if they are moving with the same speed, you can take off the common factor of the speed because they have the common speed, right? So let's go to example number 1. Example number 1. A trolley A with mass 4 kg moves to the right at 6 meters per second and collides with another trolley B with a mass of 8 kgs that is moving to the left at 2 meters per second. After collision, B moves at 3 meters per second to the right. Calculate the magnitude and the direction of A's velocity after the collision. Okay, so we have car A or trolley A with this mass 4 kg which moves to the right, okay, and collides with another trolley B of 8 kgs that is moving to the left or right 2 meters per second. Then after the collision, B moves at 3 meters per second to the right. Calculate the magnitude and the direction of A's velocity. So if you can check the SI units, kgs, correct, meters per second, correct, kgs, correct, meters per second, correct, meters per second, correct. So there is nothing that need to be converted. We have the diagram here that makes this very easy. So we have before collision and after, which means here we have final, here we have what? Initial, right? So these are initial velocities. It is very nice because we are given the directions. So we need to choose. We used to say east must be positive. East or right must be positive. So which means this one is directed to the east. So this one is positive. Therefore this one is negative. This one is positive, right? So we have the mass. So the mass here is still 4 kgs. So the mass here is still 8 kgs. Then the question says calculate the velocity after collision. Okay, let's work on it. Remember, we said the total linear momentum in an isolated system is conserved. The sum of the momentum initial is equal to the sum of the momentum final. So we have two objects A and B, which means we have momentum initial for A plus momentum initial for B. If we have the third one, we say plus momentum initial for C, which is equal to momentum final for A plus momentum final for B. So this is the same as mv initial for A plus mv initial for B, which is equal to mvf A plus mvf B. All right, so we can substitute. This is initial, that is before. So A is 4 kgs, so we have 4 times 6, that is A. The mass for A is 4, the velocity is 6, plus the mass of B is 8, times the velocity is minus 2, which is equal to 4 times, we don't know the velocity, that is final velocity of A, plus 8 times 3. Okay, so the answer here is 8. If you press calculator here and here, you get 8, which is equal to, so that is 4v final plus this one supposed to be 24. Then you transpose, we have 8 minus 24, which is equal to 4 VFA. So 8 minus 24 supposed to be minus 16, which is equal to 4 VFA. Then we divide by 4 both sides. So the final velocity of A is equal to minus 4 meters per second. Therefore, the final velocity of A will be equal to 4 meters per second. Now the direction is A was moving to the right. Then we take right as positive, which means is moving to the left now. It's moving to the left. So to the left. All right, let's go to example number 2, or question number, that was the only question. Let's go to example number 2. Example number 2, a boy with a mass of 50 kg runs at 6 meters per second and lands on a 2 kg cat that was moving at 2 meters per second. So a boy with a mass 50 kgs runs at 6 meters per second and lands on 20 kg cat. So we have the velocity of the boy in this direction, that is to the right. Then we have the cat to the right, it's also moving in this direction. Okay, then the question says calculate the velocity of the cat and the boy if he runs from the back and jumps on the cat. Okay, so if it runs, the boy runs to this direction. Okay, so what we are going to do, we are going to use the conservation of linear momentum. Sum of the momentum initial is equal to sum of the momentum final. Okay, so we have the boy and the cat, so we have mv initial of the boy plus mv initial of the cat, which is equal to mv final of the boy plus mv final of the cat. Let's take right as positive, this one is positive, this one is positive, same direction. All right, now we are looking for the velocity, that is the final velocity of the boy and the cat, right? So what we are going to do, remember they will move together at last with one velocity. They will have one velocity, that is common velocity. Okay, they will have only one velocity after the boy jumped to the cat. So let's substitute. The mass of the boy is 50 kgs, 50. The initial velocity is 6, plus the mass of the cat is 20 kgs times the initial velocity is 2. The mass of the boy is still. Now we can take off the common factor because they have the common velocity. So we'll have the common velocity. So we have the mass of the boy, which is 50, plus the mass of the cat, which is 20. Okay, so we press calculator here. So we get 340 here, then here we get 70, then we divide by 70. Okay, therefore the final velocity will be equal to 340 divided by 70. We get 4,86 meters per second to the right. That is the velocity of the cat and the boy when the boy runs from the back. Now the boy runs from the front and jump. That was number 1, 2.1, then 2.2 now. So I will just substitute from here. The mass of the boy is 50. Now if the boy is moving from the front, which means is jumping in this direction with that 6 meters per second. So since the direction is not the same, so this one will be negative now. I will just change that sign. The mass is 50, but now 6 is negative. Otherwise everything is the same. So it's 50 plus 20. So let me press the calculator. So here we have 260, negative 260, then here 70. So we divide by 70. We have negative 260 divided by 70. Then we get the final velocity, which is equal to negative 3,71 meters per second, which means the final velocity of the boy and the cat is 3,71 meters per second to the left. Then we are done with this question. Don't forget to subscribe and share the video to your friends. Thank you. Let's go to the next video, which is elastic collision and inelastic collision. Sorry.